Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on discrete distribution, population mean and standard deviation, and expected value. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos, and this is part 3 of this set on this PowerPoint. And I'm going to start with a summary from the previous video so that we can remind ourselves what our 3 formulas are for the mean, which is the mean equals the sum of x times p of x. Sigma squared, which is the variance, is equal to the sum of x minus the mean squared times p of x. And the standard deviation is equal to the square root of sigma squared. And these are our 3 formulas for a discrete distribution to find the mean, variance, and standard deviation. A better or easier way to do these, especially as your numbers get larger or the number of numbers gets larger, is a table, or to use a table to keep up with your data. So still using that same example, we're going to use a table to calculate these same values. And tables will help us organize and keep the numbers straight. Or maybe I just think so because I'm a little OCD. Let's start with the formula for the mean. And that is the mean equals the sum of x times p of x. And since I need to find each data value times the p of x, I will do so in the next column. And remember, in the order of operations, we have the sum and the multiplication, and we'll need to multiply before we add together. So we'll use that column. We'll put that at the top and label our column clearly so we know what we're doing. And remember that this is where we had said before in our previous videos that 20% of the time we get a 10, 30% of the time we get an 11, and so forth and so on. But now we'll just generate these numbers quickly and have a way to organize ourselves. So you're simply multiplying 10 times 0.20, 11 times 0.30, and so forth and so on. Now, I'm not going to multiply these numbers out or read these numbers. You can do that as you watch this video. I'm more about how we're organizing this at this point. Next, remember, the next step in following the order of operations is to add up those multiplications, or to add up that column. And again, that gives us a mean of 11.4. Either way, to find the mean is okay, and we get 11.4 as our mean. Next, we will look on how to get the population variance. Looking at the formula, let's follow our order of operations and use our table. Remember, the first step was to subtract each value from the mean, that x minus the mean inside the parentheses there. And we have x minus mu that we'll put at the top of the next column. We'll fill in each of those values underneath there. And again, I'm not going to go through that. You can pause the video and watch that. Next in our order of operations would be to do the exponent. Remember that we do exponents before multiplying. We did what's inside the parentheses first, then the exponent. So our next column will need to be to take those values we just got, the x minus the mean, and square them. And as you square those, please remember that those values will need to be in parentheses if you're using your calculator, because a negative times a negative will give us a positive, and that's why all of these values are positive. The next step is to do the multiplication, which is then to multiply the values we just got by the P of X column. 20% of the time we get the first row, 30% of the time we get the second row, and so forth. So we want to take each of those values and multiply by the P of X column, and that then gives us these last numbers in our column. We now have calculated the formula and the third step in our process. We have found the sign differences, we have squared them, we have multiplied them by our probability, and we're now ready to add those together. If we add those together, we get 0.84. And that adding works like a grouping symbol, and it is last because of the order of operations. And our variance is the 0.84. And to find our standard deviation, we take the square root of 0.84, which is 0.9165. And that is how we can use a table to get those same answers. Here is a problem for you to try. And this is another good place to stop. And please watch the next video where we will talk about some expected value. And thank you for watching this part 3 on this video series on probability distributions. If you need additional help and are a Walters State student, please come by and see me in the math lab in MBSS 222.